Hello everyone, welcome to week 5 live session for NPTEL Digital Circuits course. I am Om Maheshwari and today we will solve some questions which will help you with your assignments as well as your exams. So this is the course outline. So in week 5 mainly we have arithmetic circuits, code and converters, and mainly most of the questions are on multiplexers and decoders also. So let us go ahead. So let us begin with multiplexers. What are multiplexers? So multiplexers are uh, logic circuits where we have like this. This is a 4x1 multiplexer. That means it will have four inputs and one output and two select lines. These select lines are used to select which of the input will go into the to the output. So these S0 and S1, these are the two select lines. And as you are aware, these two variables can take four combinations. So when they are both 0, 0, the first one would go as into the output. When it is 0, 1, the second one will go in 1, 0, the third one, and 1, 1, the fourth one will go. So this is the truth table we can say for the multiplexer or mux. And if you want to write the output, we can write it as follows. And similarly, the opposite of the mux is demux. So in demux, we have one input which can go to four outputs based on the select lines. So if select lines are 0 and 0, this input will go to the first output. Is 0 and 1, it will go to the second one, similarly third one and fourth one based on the select line conditions. Okay, so let us see the first question. Do we have something in chat? There's doubt in assignment week 4 question. Okay, we can take up the those questions at the last. First, let us do the questions that I have given you. If there are any doubts, we will take them at the last. Okay. The first question is the number of select lines required in a 1:n demux is. Can anyone answer this? We just saw here, right? If there is one input, there are 2 to the power n outputs in demux. So the number of select lines, n select lines. So this is the question. Is a 1:n demux. What is the answer? Right. Log 2n is the answer. Simple, right? If these are like 4, if n equals to 4, then the select lines are log base 2 4, which is 2. Is this clear? Please feel free to stop me at any time if you have any doubts. If you're not speaking, I am assuming it is clear. Okay, so maybe we can move to the next question then. Find the canonical POS expression of function f ABC for the given figure. So this is a mux circuit and we have some inputs here. These are two are the select lines. We have to find what is the function f of ABC. So maybe I can help you solve this one. So what we can do is we can write the truth table. Then it is 0, 0, 0, 1, 1, 0, 1, 1. We know how mux works, right? When both are 0, this I0 will go to the output. It is 0, 1, this one, 1, 0, this one, and 1, 1, this one. So whatever is connected, we can directly send it. In 0, 0, this A will go into the output. So this will be A. In 0, 1, in this case, it is A bar, right? This is not gate here. So A bar will go into the output. In 1, 0 case, the I2, 1 will go. In the last one, it is 0. So based on its truth table, we can write what is F. F equals to A B bar C bar plus A bar B bar C plus B C bar plus last is 0 multiplied by something, so we will not write that. So this is the functional form of F, which we deduce from this truth table. Right? Please let me know if there is any issue anywhere. Now you have to tell the SOP form. Okay, so there are a few ways to do this. What you can do is maybe make a K-map and directly give in terms of the number. So uh, what I will do is, okay, simply what I can do is A B bar C bar plus A bar B bar C plus A bar I will do and B C bar, which is B bar C bar plus A bar B bar C plus A B C bar plus A bar B C bar. Now this is actually the POS expression of F. Oh, sorry, this is SOP. We need POS. So if we see what is this, this is 1 0 0 0 0 1 1 1 0 0 1 0. So this is 2, this is what 6, this is 1, and this is 4. So your SOP expression is 1 2 4 and 6. So POS expression will be 0 3 5 7, whatever is remaining. So here this will be our answer. This is the POS form. So I forgot to include the options in this question, but yeah, this is your answer in POS form. Yeah, please go ahead if you have a doubt. Is this question clear to everyone? So what we did is we looked at this mux. We deduced this truth table from the mux. Then we formed the expression with the help of this truth table. And then we write the SOP form, and whatever littles are remaining, those are the POS form. Okay, so I'll move ahead then without wasting time. The following circuit diagram, the propagation delay of multiplexer, NOR gate, and inverter are 2.5 nanoseconds, 4 nanoseconds, and 2 nanoseconds respectively. If all inputs P, Q, R, S, and T are applied at the same time, calculate the maximum possible propagation delay in nanoseconds to the output Y. So we have multiplexer is 2.5 nanosecond, NOR gate is 4 nanosecond, inverter is 2 nanosecond. We have to find the maximum possible propagation delay. Please attempt this. Yeah, that's correct. So once we have, if we take t equals to 0, what we will get? The propagation delay would be, if t equals to 0, it is 0, here it will be 1. So this path will go here and this path will go here, right? So it is 4 plus 2.5 plus 2.5. Whereas if t equals to 1, what will happen is t equals to 1, then this delay will come, then here and here, and this 2 nanosecond will also. Sorry, here, this and this will be the delay. This 2 nanosecond, these 2 nanosecond will happen simultaneously. Y delay will be 2 nanosecond plus 2.5 of the first mux plus 4 nanosecond of the second mux. Oh, sorry, the NOR gate, and then the second mux 2.5, which is
Sir,
11. Yes,
your voice is not audible.
I am not audible. Just a moment. Is it audible now?
Yes, sir.
Okay, I'm sorry if I was not audible before. Do you want me to repeat any question?
No, sir, it's okay.
Okay, thank you. So, yeah, so the maximum propagation delay will be there when this t equals to 1. In t equals to 1, it will be this path and this path, right? So we will have 2, 2.5, 4, and 2.5, which is 11 nanoseconds. Is this clear to all? Okay, so I'll move on to the next one. Determine the inputs of the given 4 cross 1 mux to make the output Q as xy plus z, where x is the MSB, z is the LSB. Use x and y as the select lines. So we have x and y as the select lines, and we need to give the inputs to make Q equals to xy plus z. So does anyone wants to attempt this? If they can, they want, they can take some time. Then I'll solve it. Okay, so let us solve this. Maybe I will solve this. Yeah. So there are certain steps to this question. So we need Q equals to xy plus z, right? So and we have the mux. We do not know the inputs. We know output is Q. This is x and y. This is S1, S0. Okay, so the first step to this question is expand the output to standard canonical SOP form and find the minterms. So what we have is Q equals to x, y plus z. So to make it standard uh, SOP form, what we can do is x, y, z plus z bar plus x bar into y plus y bar into z. Right? This is how we convert in function into standard form. Whichever littles are missing, like here z is missing in this term, you multiply z plus z bar. Here x and y are missing in this term, you multiply with x plus x bar and y plus y bar. So we get x y z plus y z bar plus x y z again plus x x bar y z plus x y bar z plus x bar y bar z. So this x y z is same. Now I will write the minterms. This is so This is what? This is 001. This is 101, 111, 110, 011. So it is 1, 3, this is 1, this is 3, this is 5, 6, 7. Okay, now we have found the minterms. So this is Q. The second step is draw a table between inputs and select lines. So what does this mean is, let me show you how to draw this. D0, D1, D2, D3, these are our four inputs. Stick it here. So this will be X bar, Y bar, X bar, Y, X, Y bar, X, Y, right? And this is, I can write here, let's say Z bar and Z. So if I want to write this, this is what? X bar, Y bar, Z bar, which is 0. X bar, Y, Z bar, this is 2. X bar, Y bar, Z bar, 4. X, Y, Z bar, which is 6. X bar, Y bar, Z, 1. X bar, Y, Z, 3. X, Y bar, Z is 5. X, Y, Z is 7. Now the minterms that we have, we will circle those minterms. We have, what we had is Q equals to sigma m 1, 3, 5, 6, and 7. 1, 3, 5, 6, and 7. Now, we will get the final values of D0, D1, D2, and D3. So if the circle is in the row corresponding to Z, your input should be Z, Z, Z. But here the input is corresponding to both Z and Z bar. So simply it will be Z plus Z bar, which is 1. So the input should be 1 here. So these are your inputs to the mux. D0 is Z, D1 is Z, D2 is Z, D3 is 1, which is option A. And Rohit, I think, gave the correct answer. Is this clear to everyone? If there is any doubt, please feel free to ask. So let me just give an overview what we did. We knew the output. We had X and Y as the select lines. We wanted to know what should be the inputs to get this function. So for that, what we will do first, we expand this function into the canonical form, write the minterms, then we draw the table between inputs and select lines. So these are the inputs D0, D1, D2, and D3, which are essentially X bar, Y bar, X bar, Y, X, Y bar, and XY. These are the select lines which select these inputs. Right? And here we write Z and Z bar, which is our remaining variable. Then we write corresponding to X bar, Y bar, Z bar. This position will be 0. X bar, Y, Z bar. This position will be 2. Similarly, X, Y, and Z, this position will be 7th. Now we circle those minterms where which which describe our function. If it circles in the Z row, we write Z. If it circles both the rows, we write 1. Similarly, if it circles only in, let's say, in the top row, we will write Z bar. Or if it circles none of the two rows, we will write 0 as the input. So we have our inputs then Z, 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 and 1, which is option Y. I think, okay. So the next question is, an 8 cross 1 multiplexer is used to implement a logic function Y as shown in the figure. The output Y is this. We have to find what will be the output Y. These are the inputs and these are the select lines A, B, and C. So you have to give your answer in terms of minterms. Please try to attempt this. Okay, so let us see this one. So we have A, B, C, and C as select lines. So let me just write here. When will this I0 input be selected? When it is A bar, B bar, and C bar. A bar, B bar, C, A bar, B, C bar, A bar, B, C, A, B bar, C bar, A, B bar, C, A, B, C bar, and A, B, C. Right. So your Y is equals to,
Sorry, your mic is muted.
sorry, I'm having a lot of mic troubles today. Yeah. So what I did was I just wrote the conditions of the select lines which will select these particular inputs. I0 will be selected when you have A bar, B bar, and C bar. I1 when A bar, B bar, C, A bar, B, C bar for I2. Similarly, A, B, C for the last I7. Now, whichever are of the inputs are non-zero, we will write those in outputs. So first is this one. This gives you A bar, B bar, C, and D. So how do we do this? Is simply write this select line combination multiplied or ANDed by whatever is the input. Plus we will have A bar B C D plus A B C bar into 1. And this 1 is nothing but D plus D bar, right? So what we can write is, to write the minterms, this is 1 1, sorry, 0 0 1 1, which is 3. It is 0 1 1 1, which is 7. This will be 1 1 0 1 and 1 1 0 0. 1 1 0 1 is 13 and this is 12. So your minterms are 3, 7, 12, and 13, which is option B. Is it clear? Harsha, you have answered D. Uh, have you identified your mistake? Okay, great. So if there is no doubt, we will move on to the next one. Okay. The question is, what should be the value of D0 to D7 so that the minimized output F equals to A into B plus C? So we have to give all these outputs, all these inputs, sorry, to get F equals to A into B plus C. Expand this. This is D0, D1, D2, D3, D4, D5, D6, and D7. Here all the inputs are C, here all the inputs are B, here all are A. Okay, and these are your options. Do we have any answers? Okay, so let us solve this. First step again, we will just try to expand this. What is this? Is AB plus AC It will be A B C plus C bar plus C plus A B bar plus B into C, which is ABC plus ABC bar plus A B bar C plus ABC, which is repeated. So I won't write it again. So this ABC is what? This is 1 1 1 1 1 0 1 0 1. Okay. So for your output to have, so let us see. In all the cases, output is A. There's not A bar, no A bar. So if in your select line in this mux, if input is A, so which select line it will be selected? This one, right? This path will never be selected. We do not have A bar. So let us draw the path for, let us consider ABC one first. For first path will be this, then B is also one, so this, then C is also one, this, right? So D7 should be 1 to get ABC term. When D7 is 1, your output here will be C, here it will be B into C, here it will be ABC, right? Okay, so now let's take the next term, which is 110. So 110, the path is same, 1, 1 is same. Then for C, we have to take 0, which is given by D6. So I'll make the path again, the green path. So D6 should be 1 to enable this. Here we will go, here C bar will go, then here C bar B is the output, here A B C bar. And the next one is 101. 101, this is 1, this is 0, this is 1, right? So D5 should be equal to 1 to enable this. Here we will have C, here we will have B bar C, here we will have A B bar C. So these three should be 1, rest all should be 0. So our answer is option D. Harsha has given the right answer. Is there any doubt? Is it clear to everyone? Okay, great. Then let us go to the next question then. Question is, design a 4-bit odd parity generator using 4x1 multiplexer. Consider AB as select line. So what you have is you have a 4x1 mux with I0, I2, and I3. We do not know these inputs. You have to find these inputs. And select lines are A and B. This is S1, this is S0. Your output Y is odd parity generator. So to solve this, first you must know what is odd parity generator. So odd parity generator is when in inputs, when you have even number of ones and odd number of ones. When you have even number of ones, your output should be 1. When you have odd number of ones, your output should be 0. Right? This is a parity generator. You want to generate odd parity. You want to generate odd number of ones. So when there are even number of ones, you generate a one to make the uh, whole byte as odd. When there are already odd number of ones, you do not generate anything. You generate 0. Let the whole number should have odd number of ones. So if these are your inputs, let me write it properly. Is A, B, C, D are your input, then one should be Y. So Y will be when you have even number of ones, output will be 1. So here you have even number of ones, here it is odd, odd, even, odd, even, even, odd, odd, even, even, odd, even, odd, odd, even. Right? So your minterms are this is 1, 2, no, sorry, 0, 1, 2, 3, 4. Basically all the even numbers. Actually, no, this is not correct. I think, yeah, all the even ones, yes, parities will be 0, 3, 5, 6, 9, 10, 12, and 15. Okay, so these are your minterms. Now what we can do is we can again make this kind of table, but it will be bigger this time. So what we can do is make it just like K map itself. So these are your select lines A, B, and these are your inputs that you should have. 0, 1, 3, 2, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. And your ones are at 0, 3, 5, 6, 9, 10, 12, and 15, right? This A bar B bar, what is A bar B bar? A bar B bar is I0, I1, I2, I3. So what is I0? I0 equals to, should not have written it XY, this is CD, sorry, C bar D bar, C bar D, CD, CD bar. So I0 is A bar B bar, C bar D bar, or A bar B bar is obvious for, you can write this I0 is C bar D bar plus CD. I1 is C bar D plus CD bar. I2 is C bar D bar plus CD. I3 is C bar D plus CD bar. So this is essentially C XOR D. This is C XOR D, C XOR D, C XOR D. So your outputs, sorry, input I0 is C XOR D, I1 is C XOR D, I2 is C XOR D again, I3 is C XOR D. Your answer is options C, I think. Hmm, did I do some mistake? I0 is XOR, I1 is XOR. Okay, this is wrong. None of these are correct. Okay, so is this clear? What I've done here? I've done essentially the same thing what we did earlier. Here we had a smaller K-map since we have only three inputs. So this is nothing but K-map, right? Z bar, Z and X, Y, right? This is essentially a K-map. Same thing we have done here. We have made a larger K-map, and for I0 we have C bar D bar plus C plus CD. I1 we have C bar D plus CD bar. I2 we have C bar D bar plus CD, and I3 we have C bar D plus CD bar. So this is XNOR, this is XOR. Are there any doubts in this question? Okay, I hope it is clear. Let us go to the next one then. Deduce the expression of the circuit shown below. Can anyone tell me the expression? Okay, so let us solve this. Here we have W, here W bar. So output here is, let's call it Y1, call it, let's just call it Y. So Y is S1 bar W plus S1 W bar, which is essentially Y is S1 XOR W, right? Now, what is S2? What is F? F is S2 bar Y plus S2 Y bar. So F is also S2 XOR Y. Now we put the value of Y. F equals to S2 XOR S1 XOR W. So this is your F. Simple question, right? Is it clear? Okay. Let's see the next one then. A 3 to 8 decoder is used to implement the function F. What is the expression of F? So when input is A bar, B bar, C bar, this Y0 will go to the output. Similarly, A bar, B bar, C, A bar, B, C bar, A bar, B, C, A, B bar, C bar, A, B bar, C, A, B, C bar, and A, B, C. Now, these are going into your NAND gate, and these are bubbled. All the outputs are bubbled, right? So it is going into NAND gate, which Y0, Y0 bar, Y2 bar, Y3 bar, and Y7 bar. So when we have a bubbled NAND gate, let's say this is X. What you can say, let's say it is J and K. This is Q. So this is J bar, K bar. So Q equals to J bar dot K bar whole bar. which is simply J plus K. So a NAND gate whose inputs are bubbled is nothing but a OR gate. So this is nothing but OR gate. So your output F is Y0 plus Y2 plus Y3 plus Y7, which is 0, 2, 3, and 7, which is option B. Is it clear to all? Okay, so let us move on to the next one. Identify the output Y of the following circuit. Please attempt this. Okay, so let us see this one. So this is easy, right? So here we can make the truth table. A, B, and Y. 0, 0, 0, 1, 1, 2, 1, 0, and 1, 1. So when it is 0, 0, Y, C, C bar, 1, and 0. Right? So Y is essentially A bar, B bar, C plus A bar, B, C bar plus A, B bar, C plus A, B, C bar. Sorry, this is 0, this is 1, right? That is A, B bar, which is A bar, B bar, C, A bar, B, C bar plus B bar, C plus C bar. This is 1, this is 2, this is what 5, and this is 4. So your Y is sigma n 1, 2, 4, 5, which is option B. Harsha, your answer is correct. Is anyone else attempting, or you guys are gonna watch this later? Okay, so I hope this is clear. Next one. The number of select lines for 32 cross 1 multiplexer is, which is log base 2 32, which is 5. Right? Option B. Right? 32 is 2 to the power 5. Okay. Next, identify the following circuit. So in your circuit, this is what you have is your output is D0, D1, D2, D3. You have one input. So let's say data, some input, and you have two select lines S0 and S1. What is this circuit? Correct. It is 1 cross 4 demultiplexer. Okay. So I have already mentioned the answers. So we have to find what is the output. This is a very easy question. Okay, so let's do this. Here your input is 1, so this I1 will be selected as output. So at I1 we have 1. Here it is 0, so this X will go to the output, and here it is Vx. Here it is again 1, so this I1 will go into output, which is X. So output is X. Very simple question. I hope it is clear. Okay, so next question is, how many multiple multiplexers is required to implement the function f abc equals to 0, 1, 2, 5? What could be the answer? B, correct. So we have a mux. Let's say we have a three variable function, right? A, B, and C. You can have A and B as select lines, and in the four inputs, there can be some combinations of C. You will have one output F. Can anyone tell me what could be the inputs? So it is I0, I1, I2, and I3. What could be the inputs to make sigma m01 f equals to sigma m0, 1, 2, and 5? 0 is A bar, B bar, C bar. 1 is A bar, B bar, C. 2 is A bar, B, C bar. 5 is A, B bar, C. So what should be I0, I1, I2, and I3? I0 should be 1, right? It is A bar, B bar, C plus C bar. So both are there, so it should be 1. And I1 is A bar, B. So A bar, B, we have C bar. Then will be C bar. I2 is A, B bar. And the digit is C. And I3 will be 0. We have nothing multiplied by AB. I0 and I2 should be C bar, Harsha says. Are you sure, Harsha? What is this? This is A bar, B bar, A bar, B, A, B bar, and AB. In our terms, we have A bar, B bar multiplied with both C and C bar. So it should be 1. Then we have A bar, B. A bar, B is multiplied with C bar. So it should be C bar. A, B bar is multiplied with C. So it should be C. And AB is not in the terms. So it should be 0. Is it clear, Harsha? Great. Okay, so anyways, the answer is B. 4 cross 1 marks. Does anyone else have any doubt? Okay, so this is the last question that I have for today. Question is, the Boolean function f is implemented in the figure using two multiplexers. What is f? Okay, let us see this one. You have your output is E, right? So E is B bar C plus B C bar. Then you have F. F is A E. So it is A B bar C plus A B C bar. So your answer is option A. Okay. All right, everyone. So these are all the questions that I had. If you have any doubts, you may stay back and ask. Others may leave if they want. Vishwanath, you had some doubt, right? Yeah. In which question, Vishwanath? Yes, sure. Please unmute.
Sir, in week 4, there is one assignment question. Let me just read it. 14th question, sir.
Okay, just a minute. Let me open the question. Okay, so question 14 is which of the following statements is false? A, parity checking circuits. This question?
Yes, sir.
Okay.
Sir, which of the following is false? But actually, option A is also false, no, sir. It is used for only detection, but not for correction, right?
Parity checking circuits are used for error detection and correction. Parity generator circuit generates a parity bit before transmitting. Parity checker circuits checks the parity at receiver. Even parity checker output logic 1 when it contains even number of logic ones. Okay.
Option D and A both are wrong, no, sir.
Just a minute. Okay, so why A is wrong?
Sir, it is used for only detection. It gives, I mean, if there are odd number of ones, let's say,
Hmm.
even parity checker gives output 1.
Okay.
But it is not, I mean, we cannot correct the error from the data that we have obtained. No, sir.
No, once you know where is your mistake, you can correct it, right? Why can't we correct it? Once you have
Sir,
detected your mistake.
it just informs us whether the bit is 1 or 0. But which bit is error or how to correct the error, there is no procedure, no, sir. For that, we have other types of like Hamming code, checksum.
Okay, you might be correct. So yeah, I kind of agree with you. So what you can do is maybe post this in your forum. Do you know how to access that?
Yes, sir. I have already posted it in doubt session, doubt forum, sir. But I haven't received any response from it.
Maybe you can just put a reminder there because I think correcting this re-evaluating assignment is not in my hands. Only those who control this forum can do that, I think.
Okay, sir. Can you please tell how to post it? I have posted it in the doubt forum.
Yeah, that same forum. You can post it again.
Okay, okay, sir. Thank you, sir.
So until you receive a reply there, keep posting it.
Okay, sir. Actually, marks were graded and they
Yeah,
were
that
awarded.
it's fine. They if there is some question which is incorrectly evaluated, they regrade it.
Okay, okay, sir.
Yeah.
Thank you,
So
sir.
Yeah. Is there another doubt?
sir, can we get the solution of these in PDF form for all these problems?
What I have solved?
Yes, yes.
Yeah,
Or
definitely.
for
We
all the problem solving sessions, like
yeah. If you open that, do you know the Google Sheet where we have those
yes,
problem
yes,
solved?
I
There,
have it. Yes.
yeah, there is a link in between where there are all the PDFs.
Okay, for PDF also, right? I
Let
I
me
saw the.
let me show it to you. Just a moment.
I saw the YouTube recording.
Uh, what you can do is you go on this problem solving session, click here to view, and my links are these ones, and here in this one, this middle, there's link to all the PDFs, right? This presentation link, Google slide link. Here I have
Okay.
all the older solutions also.
Can
I
we
will
get
upload.
some more problems for practice? So,
I will share if I have any more. I will share it with you.
all right. Thank you, sir.
Yeah. Okay. Is there any other doubt? Let's see. Can you solve question 12 from assignment 4? Let us see what is question 12 from assignment 4. Just a moment. Question 12 is consider the circuit shown below. Which of the following statements correctly describes the output X? Okay, let me share this again. So this is question 12, right? Sorry. X is the generated out carry bit. X is equal to logic 1 when addition is performed, and X is equal to logic 0 when subtraction is done. X is equal to logic 1 when there is an overflow during either addition or subtraction. X is equal to logic 0 if there is an overflow during addition or subtraction. Okay, let us try to see this. So we have this circuit. Okay, so what's this S? Can anyone tell me? Has anyone solved this question in their assignments?
Yes, sir.
What is S?
Sir, actually tried it in another way.
Hmm.
Overflow concept we have tried it, sir. Let's
Okay,
say for plus 7 we use 3 bits to represent
okay,
in one's complement form.
okay.
There is a chance of overflow, sir. Plus 7 plus 7, which gives result of plus 14. We cannot represent plus 14 within 3 bits now, sir.
Yeah,
Similarly, the same case occurs when minus 7 also.
but here you have 4 bits, right?
Yes, sir. Just a minute.
You have 4 bits. Let's say 1111 plus 1111. It will be, this is your overflow, right? So this overflow bit would go to C4 will be 1. Let's say I do 1111. I have to do this addition. C0 is 0. So F0 will be 0, 1, 1, 1. All these carries would be 1. C2 is 1, C3 is 1. So for this 1 and 1, this should be 0, right? When it is overflow. Hello? Sorry, I forgot who was explaining their answer. Is What was the logic behind this answer C? Can anyone explain?
Sir, if we consider plus 7 and plus 7, uh, triple one is, I mean, binary form, no, sir.
Okay, let me write triple one.
0 triple one.
Okay, you want me to write 0, triple one. Okay,
Yes, sir.
fine. Then,
Similarly, for plus 7 again 0 triple one.
okay, you want me to add it?
Yeah, yes, sir. So the answer would be yeah, yes, sir. But it is in 2's complement form, so MSB is 1, so it is a negative number.
For addition, why do you need two's complement?
I didn't get it, sir.
We are doing addition, right? Why do you need to do two's complement for
Yes, sir.
addition?
If MSB is 1, then we consider it as a negative number and we again perform 2's complement to obtain the original number.
That we only do if when we are doing subtraction.
Yes, sir, but this is the concept of overflow where here MSB comes out to be 1, so which is negative.
Okay,
Answer,
fine.
if we
Let's say it is negative. So then,
so if you apply 2's complement, the answer comes out to be -2.
-2. Okay.
From this, we can understand C3. Where is C3? Carry 3 generated.
Yeah. This is C3.
Carry 3 from. I mean, we took example now, sir. +7 and +7. C3 we are getting it as 1, and C4 we are getting as 0. Carry from fourth bit. I think you have understood, sir. From C3 we are getting one carry. 1 plus 1.
Yeah, that is fine.
From fourth we are not getting any carry, so output is 1, sir. Odd one detector. Similarly, it happens with -7 and -7 also, sir. This is due to because we cannot represent +14 in 4 bits now, sir. We required 5 bits to represent +14. One for sign bit and other 4 bits to represent magnitude.
Okay. I don't get it properly because I am in doubt because here the inputs are all 4 bits. So if you do this addition, there these two always must be 0 if you're considering a sign bit. But there's nowhere stated where this is a sign bit. Okay, so I cannot conclude on this. Who asked this? Azim. Azim, sorry, I do not know the answer. Maybe again we can go to the doubt forum and someone can explain this one. I am not sure exactly. I understood what you are saying, but I am not very satisfied with this explanation because what I am thinking is simply if I have to do if I have 4 bits 1 1 1 1 1 1 1 1, my output should be 0 1 1 1. These are the carries, right? So C3 will also be 1, C4 will also be 1. So 1 and 1 should be 0. That's what I'm thinking. However, this is not necessary. The C3 will always be 1. It can be any combination 1 0 also. Then also you will have an overflow. Okay, so is there any other question apart from this? Okay then. Thank you everyone for joining. I will look into this question. I will try to get the answer. I will ask other TAs. So maybe we can discuss this next time if we get a chance. Thank you everyone for joining. See you.